Hey guys, welcome to another Chemistry 151 GLA. It's James, and today we're going to be talking about problem number 7 on GLA number 15. So the problem reads, how much 0.055 molar barium hydroxide is required to reach the equivalence point when titrating 16.7 milliliters of a solution of 2% mass per volume acetic acid. So the first step in doing this problem is we need to write a balanced chemical reaction. So we'll go ahead and do that first. We have acetic acid reacting with barium hydroxide, and that's going to be an acid-base reaction. So that's going to yield an H2O liquid as one of our products plus something else. So we'll go down here and say we have HC2H3O2 plus barium hydroxide is going to give us at least one water molecule, and that comes from the hydroxide bonding with the H. So the other product is going to be barium acetate. We'll go ahead and write the phases for all of these. This is going to be aqueous. The barium hydroxide is also aqueous. Water that's produced is going to be a liquid, and the barium acetate is going to be aqueous as well. Let's go ahead and look at the charges on these. Hydrogen is +1, acetate is -1. Barium has a +2 charge. Hydroxide itself has a -1 charge. Water we don't have to worry about because we know it's balanced already. Barium is +2, and because acetate is -1, we're going to need 2 of them to balance out the charge on the barium. So now that those charges are all balanced, let's go ahead and balance out the number of atoms on both sides. On the left side, we have 2 carbons, 3, 4, 5, 6 hydrogens, and 2, 3, 4 oxygens, and 1 barium. On the right side, we have 4 carbons. We have 6, 7, 8 hydrogens, 4, 5 oxygens, and 1 barium. To balance out the number of carbons, I'm going to put a 2 out here in front of acetic acid. That's going to change the number of carbons we have to 4. The number of hydrogens we have now is going to be 6, 7, 8, 9, 10. We're going to have 4, 5, 6 oxygens, and we still have 1 barium. So on the right side, to balance out the hydrogens, I'm going to put a 2 out here in front of the H2O. That's going to change the number of hydrogens we have to 10. We now have 6 oxygens and 1 barium. So this is the complete and balanced chemical equation. I'm going to go ahead and erase all this because we don't need them anymore. Now we're starting with 16.7 milliliters of an acetic acid solution. So I'm going to say 16.7 milliliters of HC2H3O2. And it is a 2% mass per volume solution. So if we have 100 milliliters of this solution, 2% of it is going to mean that we have 2 grams of HC2H3O2. Next, we're going to use the molar mass of acetic acid to get the number of moles that we're dealing with. And acetic acid is 60.06 grams per 1 mole of acetic acid. So if we go ahead and do this calculation, you'll see the milliliters cancel out, the grams will cancel out, and our answer will be in moles of acetic acid. So I'll do that right here. We have 16.7 times 2 divided by 100 divided by 60.06 and our answer is 0.00556 moles of acetic acid. Next, we can do a mole to mole ratio. Because we know we have 0.00556 moles of acetic acid, because we wrote and balanced out this chemical reaction up here, we know that for every 2 moles of acetic acid, we're going to be reacting with 1 mole of barium hydroxide. So if we divide this out, these units will cancel and our answer will be left in moles of barium hydroxide. So we'll do that. 0.00556 divided by 2 is going to give us 0.00278. And that is in moles. Now we have to go from moles to milliliters, and we'll do that on the next slide. So let's just go ahead and remember we have 0.00278 moles of barium hydroxide. We're also given the molar concentration of the barium hydroxide, and we know that the molar concentration is equal to moles per liter. So we can solve for the volume by rearranging this equation to give that liters are equal to moles divided by molar concentration, and we can just plug numbers in from here. So we have that the number of liters is equal to 0.00278 moles of barium hydroxide divided by the molar concentration, which is 0.055. We'll calculate this. 0.00278 divided by 0.055, and that's going to be 0.05 06 liters. And if you wanted to keep the units in the same units that the problem was giving us, you could multiply this by 1,000. And say that it's going to be 50.6 milliliters of barium hydroxide would be used in the titration. Thanks guys, I'll see you guys soon.